So, hello and good morning, good afternoon from wherever you are joining us today. I want to welcome you to our today's Fronius International webinar with the topic Primo Gen24 installation hints. So today we are talking about system design with this product. We are talking about commissioning and installation hints. So I want to quickly introduce the team for today. So my name is Christoph Schierlinger. I'm in the team Trainings and Education at Fronius International, and I'm happy to guide you through today's webinar through the next 30 to 35 minutes. And I'm also not alone here. So my colleague Sandro is also with me today. He's responsible for the chat today. So if you have any questions during or after the webinar, don't hesitate, send your questions through. Use the chat function on the right side of your screen, and Sandro will try to answer as quick and good as possible. Before we start, I want to introduce you into the topics for today. I have clustered them here in this agenda slide. So we start with the bottom left corner here with the technical data of this product, of the Primo Gen24 Plus. And then we head on straight into the Gen24 Plus correctly installed. So installation hints, where to install it and how to install it correctly. After that, we quickly take a look into system design. So how many strings can I configure? What's the MPP tracker voltage and so on. So this is then part of this topic before we head on into a very interesting part as well, the backup solution and additional options like battery and smart meter, for example. And last but not least, we're talking, of course, about the commissioning, how to set up this product and how to bring it online onto SolarWeb. Okay, we start with the first slide with a little bit of a technical overview with this product, the Primo Gen24 Plus. Yes, it's a single phase inverter, and for all of you who already are working with Fronius, you already know that Primo, the word Primo at Fronius always stands for single phase product, and this is also the same. So we have a single phase Gen24 Plus inverter, and actually with this device we have the first hybrid inverter at Fronius for the single phase markets also. So we're very happy to have this product in our portfolio, and it's available in the power classes 3 to 6 kilowatt, so perfect for residential systems. And it is equipped with 2 MPP trackers individually working, so very flexible for system design, and also 1 separate battery input, so we can DC couple a battery to it. We also see this in a later slide then. And a very interesting part is, of course, backup functions. We have a few or 2 of them available with this product, which I also want to explain. We have the PV point and also a full backup solution. I will explain the difference a little bit later. Yeah, we head straight into the correct installation, and I want to show you some installation hints. And first of all, I want to give you a hint where you can find the installation manual itself. If you ever need it, of course, it's with the product itself, but you can also find it online. I think it's a very neat way to look up something because you don't have to print out anything. It's an e-manual online on our homepage for every product right now on the market. And yeah, you just type in manuals.fronius.com and you can see it's more or less a way of the electrical installation document, and you can very easily navigate. And I think it's a very good way to also save paper in this way. Yeah, but I want to pick out the most important topics and explain it to you in those slides. We talk about the installation instructions first. Where can we install it? Yes, it's an out and indoor product, so we can, without any trouble, install it in rain, in snowy conditions. We have a very high IP protection class of 66. So the only thing we need to make sure is that there is no direct sunlight on the product, no direct irradiation, because otherwise it would get a little bit too warm, might be too warm for the product. but underneath the module or on the north side of a building in our regions where there is shade, it's no problem to also install it outdoors. As we can see in the temperature range, there is most certainly hardly a place on Earth where we can't install -40 to +60 degrees ambient temperature where we can operate, and also the humidity is no problem here, 0 to 100%. The altitude, we can install up to 4,000 meters above sea level without any input voltage restrictions on the DC side. So up to 4,000 meter, absolutely no problem. I doubt that there are there might be some cases, but in the most cases, I think we're underneath 4,000 meters, so it should be very suitable for 99.9% of the installations. Regarding the installation site, I have also put out here a few screenshots. So we can see indoor is no problem, outdoor is no problem with our IP66 class. And please make sure to have a cover over the inverter if you install it outdoors, so there is no direct sunlight on it, as already mentioned. And also regarding the altitude, above 4,000 meters, it's no good to install, but until 4,000 meters, no problem. Yeah, in the bottom line, we can see the direct sunlight. Also, we have an active cooling system. We have a central position fan. Of course, it can make a sound, and therefore it's not very suitable in a living area to install it. Also, in the near distance of livestock, it's no good because there might be a livestock who knocks it down or something else. So make sure to keep it away from livestock. Also in dusty environment, especially when there is metal dust, please make sure to avoid this area. If there is no other place to install it, please also make sure to clean it in a frequent way, like every year or something else, to just blow it out so that the cooling ribs are free to distribute the heat again. So this is the most important thing. Yeah, glass houses and also factories where there are aggressive chemicals, this is also no good place to install the inverter. Regarding the orientation or the positioning, more or less, we can install in a vertical and also up until a horizontal way without any problem. Also in a slightly tilted angle, this is no issue. The only thing we need to make sure is that it's not tilted sideways, so that the cable gland might be not doing its job anymore. So if you tilt it sideways, you could have possibly water through the cable glands into the device, and this is of course a big issue. So until you don't tilt it sideways, it's no problem. Yeah, and also at the far right, we can see here a picture with dimensions to keep clearance. Also here we can see, of course, our active cooling system needs a little bit of space also at the top, bottom, and the sides of the inverter to distribute the heat. And therefore, if you just remember, okay, 230 millimeters at minimum and on all sides, then it's a good way to remember this number. And you can also install multiple of them side by side without any problem. Okay, yeah, I've already explained this. We have an actively cooled product with a centrally positioned fan, as we can see here, and we have really a heat distribution across the whole product. So on all sides, also at the bottom, we distribute the heat, and therefore we have, of course, a few advantages. We have a later derating behavior regarding or compared to a passively cooled system. We have a longer lifetime also of the electrical components, which is the biggest issue. And yeah, so this is really the reason why we stick with the active cooling system. And yeah, here we can see how it works. Okay, then we come to our first installation process, or the first installation step, and this is to mount the wall bracket. It's really a lightweight wall bracket. It's just an aluminum, and you fix it onto the wall or onto the plate where you want to mount it. You just select the correct fixing material, a minimum of 4 screws here, and just make sure that this small arrow on the bottom right corner is on the up position. Otherwise, we couldn't mount the inverter itself on it. And also make sure that the wall behind that you are fixing it to is not too uneven. Of course, this wall bracket is compensating uneven surfaces at the greatest extent, but it's not meant to bend too much. Otherwise, again, the product itself, the inverter itself, is not possible to mount it again here. Yeah, and after that, we come to the next step, which is also very easy, of course, the mounting of the inverter itself. And it's just a snap-in mounting concept. So for those of you who are familiar with our previous product series, the snap inverter, it's the same technique. You just hang it on the top mounting handles here, and then you snap it in at the bottom, and you can hear a clear clicking sound as well. And you can also do a visualized check. So here at the bottom, we can see that the fixing is really tight and it's snapped in, and therefore we can have a visual and an audible check if it's mounted correctly. Yeah, so that's actually it for the installation process. And then we had in the next chapter, which is the system design, what can we do with this product, string lengths and so on. And of course, for that reason, we need to open the product first and take a look inside. And here again, we have the Fronius Primo GEN24 Plus device open. This is actually a look onto the bottom of the inverter. We usually have there a black cover. Maybe you remember it from the previous slides. And we just undo this cover with 5 quick lock screws, and then we can directly see into this mounting area in this installation area. Yeah, and from left to right, we can see here the DC side, both for plus and minus. They have individual mounting clamps. This is this terminal, this DC terminal for plus and minus. And we can see here the 2 MPP trackers. Both of them have 2 inputs, as we can see here. So MPP tracker 1 has 2 plus and 2 minus, and also the second MPP tracker. And I'm not sure how well you can see it, but in the black underlayment, we can see here a battery connection, also for plus and minus. So this is where we can directly connect our DC coupled battery. So this is the DC side on the left side. In the middle, we can see the data communication. This is more or less the brain of the inverter and also the communication center. So it's called the Pilot as product itself, and it's standard integrated. So there is no way that you get a light version like you could with the snap inverter. It's really not functioning without this. So it's a standard integrated, and it is the communication center. Yeah, this whole Pilot, this communication center, is covered with this separation from the connection area to just protect it from DC and AC voltages that may damage this product. And right on the side of this separation, we can see very unclear in the background a ground terminal block. So this is actually the only place in the inverter right now regarding the connection area where we have a screw terminal. It's a copper bar with 10 and 16 square millimeter cable connection points with a screw. This is for the grounding. And then right next to the grounding terminal, we see the PV point, which is actually the first backup solution that is standard integrated again with every product. And it's this single phase connection point. I will explain a little bit more later on how this is functioning, but basically the PV point is the standard backup solution available for every Primo GEN24 Plus device. And right next to the PV point, we can see the AC clamp here in case for the Primo also the single phase connection. Okay, so we head on into the actual design part where I quickly want to introduce you into our tool, the Solar Configurator. I hope you already know this tool. If not, check it out. It's a free of charge online configuration tool of Fronius. So we have developed this especially to have designers like you do a quick system design with our products with a big variety, a huge database of modules that are available on the market, and you can do a first quick check if the system design is correct in this way you have planned it. So solar.configurator, just type it into the browser. It's free of charge. Yeah, and now to the product itself. So the Primo GEN24 has a DC input voltage range going from 65 volts up to 600 volts. So this is why I marked it here in red. Very important, it's not a 1000 volt device. The maximum DC input voltage is really 600 volts. If you know Fronius, we usually did 1000 volts. The Primo is a little bit of a smaller product, and therefore we have it only up to 600 volts. So very important to remember this when designing a system with this product. 65 to 600 volts. And actually, when we think about this, we have a very broad input voltage range. So this is really a huge range. And actually starting from 65 volts on to have the tracker tracking, we can actually do very short strings as well. So this can we see in the red box on the top right here. So from 3 modules on, depending on the module you're using, you can do strings and connect it, and it is working. So a minimum of 3 strings, 3 modules per string is necessary, but that's really flexible when you think about a few roof systems where there is not enough space for a huge string. So then there you can also do a short string and connect it to the Primo without any issues. However, we need to make sure, or we need to remember, that the feed-in start voltage on our products, the GEN24 products, in grid parallel mode is 80 volts. So we need at minimum 80 volts once, and then we can track down to 65 volts and up to 600 volts. So this is the start voltage. And there is also a difference if we have a backup mode now. And in the backup mode, of course, there is no grid supplying us. So we need a little bit higher voltage to also supply the inverter itself with power. And therefore we start at 150 volts on the DC side. So there is a difference between grid parallel and backup mode when it comes to the feed-in start voltage. Regarding the input current, we have 2 MPP trackers, we already know that, and there are 2 different input currents on those, 22 amps on the first and 12 amps on the second one. And also the battery input has 22 amps, so we can really have high charging and discharging currents with this product. So that's also a huge step upwards. And all of our products, also our previous snap inverters, have the ability to oversize them, as well as our GEN24 Plus device, of course. So also the Primo here is able to configure up to 150% of over-dimensioning on the DC side. So if you pick, for example, a 10 kilowatt device, you can do 15 kilowatt peak on this product. So this is what it means with over-dimensioning without any warranty losses. Okay. So that's it actually for the system design, a very quick overview and important things to remember when doing the system design. Now we head into a very interesting topic regarding backup solutions and additional options which are able to connect and which are also necessary when we think about backup solutions. Yeah, and one necessary product is, like we can see here, the Fronius smart meter. It's really not an option, it's a necessity to have a Fronius smart meter installed when you want to have a full backup solution. And the Fronius smart meter, so unfortunately I have picked out here a 3-phase smart meter, but there is also a single-phase smart meter available, and it's the same cabling. The process is exactly the same. I will just explain it on behalf of this product here, the 65 amp 3-phase, and there is also a 100 amp single-phase one, which is very suitable, of course, for the Primo GEN24. Yeah, the biggest, most important thing is, of course, the data communication. Or before we come to the data communication, where do I mount this product? Of course, I have to answer this question first. The Fronius smart meter is installed in the at the feed-in point, so directly after the utility meter. Then we want to install the Fronius smart meter usually, because then we have a very central position where we can measure all the energy flows within our system. And by that measurement, we then also know what's going on in the system. We can distribute the energy flow to charge and discharge the battery. And in case of a backup solution, we also know exactly that the grid is gone here. And after the smart meter, we have then a backup switch, and we can measure also out of our small grid, of our backup grid, if the grid has returned. So this is the reason why the Fronius smart meter is very important and necessary in a full backup scenario. So this answers the question where we have to install it. Now the question how. And I've also mentioned that data communication is the most important thing, and we can see it here in these colors: brown, green, and yellow. That's just my visualization to separate them. So we have a 3-pole line coming from the smart meter to the inverter. This is our connection, and it's a Modbus RTU connection, RS485 data communication. And usually what we recommend is to use a Cat5 Ethernet cable at minimum, or a higher topology like Cat6, Cat7 can also be used. However, there is a few important things that you need to remember. If you use a cable, use one which is shielded. So that's why we say Cat5 at minimum. A shielded cable, ground the shield on one side. Also very important to ensure the best quality of our data. And as we can see in our slide here, there is a possibility to ground the shield on the inverter itself. We have a direct connection here, which is called shield, and this is especially meant for that reason. So we can put the ground, the shield here on this position and ground it on one side. So that's the first two important. The third one is to have a twisted cable pair between data plus and data minus. In our case, it's the green and yellow cable, and we can see here in this schematic that it's twisted to each other. So on the inverter, the connection is called M0 and M minus and M plus. So this is just another wording for data plus and data minus. This is the first important topic, the third. And the fourth and last one is to have 120 ohm resistors at the end of our Modbus line. And our Modbus RTU line, we always have a serial connection, not the parallel one. And of course, we have two ends on our line here. And on those end components, we always need to make sure to terminate it. And on the Fronius smart meter, there is a 120 ohm resistor already integrated, and we just put a short cable bridge from position 7 to 9 in this case, and we terminate this component, then this Modbus line on this end. And on the Gen24 Plus inverter, we also have a way to terminate it. This is with this little dip switch on top, which we just put it into position 1, which is the on position, and then we have both of the ends of this inverter, of this communication line terminated, and we ensure the highest data communication without any losses. So this is actually the most important things to remember when it comes to data communication and to the Fronius smart meter. Now we talk about the backup solution available with this product. And I want to start with the already mentioned and standard integrated one, which is the PV point. The PV point is the basic backup function, and we call it like that because it's really, you just have to do a single cabling onto a wall socket, and that's it. So onto this, from this cable connection that we saw in the inverter connection compartment, we just connect a single phase cable, grounding, neutral, and phase to a wall socket. Of course, it's it's not recommended to use a simple wall socket. Please also make sure that is RCD secured. So there are RCD integrated wall sockets, or you can of course separate those two. But it's very important to have it secure, a secure single phase line to this PV point. And then the PV point will activate as soon as the grid is gone. And this PV point will be supplied with a nominal power of up to 3 kilowatt. For a short time, we can also supply a little bit more. So as we can read here, for 5 seconds, we can also supply 4.7 kilowatt. So even higher power classes can be supplied here. And then you can charge your devices, you can plug in your refrigerator and so on. And very important to know is it's working without any battery. So it's not necessary to have one installed in the system, but you need to make sure that the PV point is really only working if the grid is gone. So if the grid is here and the inverter is producing and feeding into the grid, the PV point will be deactivated. So you cannot permanently plug in your refrigerator, for example. It's not working until the grid is gone. So very important to remember that. Yeah, and the good thing is, of course, there is no time-consuming additional installation. It's really just a single phase cable, an RCD, and the wall socket, and that's it. Yeah, I quickly want to give you a closer look how the installation looks like. It looks a little bit confusing at the first sight, but on top here we can see this connection compartment again, our single phase plug. And first of all, the naming, it states here 2 neutral with an apostrophe above it, and also a phase L1. Why do we have here 2 neutrals? This is the reason that we don't directly connect the single phase cable directly to this PV point. We only connect neutral and phase and the grounding cable. Before we plug it into this terminal, we go to our grounding terminal block, and from there we go then up to our PV point. And the reason for this short bridge here to the grounding terminal block is because we need to create our own PEN conductor. So because in the grid outage we are gone, so there is no grid parallel mode anymore, and the PV point, in order to operate well, is necessary to have a PEN connector here, and this is why we have to do this cabling like that. So just remember, the 3 cables don't go directly into the PV point, only neutral and phase, and the grounding cable is going first to this grounding terminal block and then up to the PV point. Yeah, we can also see down below an RCD integrated socket. So this is also what we can recommend, but of course you can do 2 separate components as well. Of course, it's possibly a price question here, what to choose, but both of them are working fine. And yeah, so yeah, for the RCD itself, and type A RCD is sufficient enough. 30 milliamps. Our type A RCD is the way that we need to secure this line. Okay, yeah, one last slide for the PV point is the adaptations we have to make on the main body. There is no cable gland for the PV point pre-installed, because not every customer uses it, of course. And if you want to use it, if the customer wants to use it, you have to pre-drill it. Like we can see here in the picture, there are predefined positions like exits on the main body that you can pre-drill, and then you have to set your own PV gland here, PG gland here for the projection glass where you can cable the PV point. This is for the cable entry and to make sure that the IP66 class is still intact. So this is the only adaptation we need to make on when doing a PV point. Yeah, and then we step ahead, and of course there are also persons who want the whole household supplied again if the grid is failing. And for that reason, of course, we also have a full backup available with this product. And for the full backup, the first thing we need to know is that there is a battery connection necessary. A full backup isn't working without a battery connected. Possible batteries that are connectable to our product are the premium BYD batteries, HVM and HVS. So in the picture here, we can see, for example, the HVM batteries. And yeah, so this is also one thing I want to explain in this slide. We can mount up to 3 towers of those batteries. So there is basically no restriction other than one. So the maximum capacity that BYD can deliver is 3 towers with 8 modules stacked up to each other. So this would be 22.1 kilowatt hours times 3. Unfortunately, that's a little bit too much for Fronius. So we have a limitation on 3 towers with 7 modules. So this would be 57.96 kilowatt hours. That's the maximum capacity we can connect to our components. But I think this is really a high capacity on this product and should be sufficient enough for mostly any residential usage. So yeah, this can be connected here, and it's necessary for a full backup. And in a backup scenario, we of course need this disconnector switch at the feed-in point that I've mentioned earlier. So this is actually then necessary to disconnect the whole system from the grid, and then it's restarting its own backup grid and supplying the whole household again with the full nameplate power of the inverter. Yeah, and then we have, of course, the possibility to have multi-flow. So we are using also if the sun is shining, we're using PV, the PV energy. We're using energy out of the battery, and if we don't need as much energy from our battery, we can also recharge the batteries also in a backup mode. So a lot of ways possible here in a full backup scenario. Okay, so that's it for the topic of backup solutions. However, there are some more options available for this product, and one would be the surge protection device, and this can be integrated into the device, the Primo GEN24. It's called DC SPD Type 1 and 2, and it's a print-based version. So like we can see here, the actual SPDs are soldered onto a print board, and it can be mounted in the connection area, like we can see in the picture at the right. So this is actually underneath the connection terminals mounted in the main body. And yeah, of course, it has the advantage that you don't need a separate box somewhere installed at the customer site. You can have all of the components inside the inverter and without any additional boxes. Very important to remember is that there is no ex-factory assembly, so you would need to order a separate component. You order this SPD from your wholesaler and build it in yourself. So it's not possible to order it assembled ex-factory. So if you're interested, just check out your wholesaler and order this article number, which we can see on the top right here. This is then the correct article number for this product. Okay, last but not least, I want to take a closer look into the commissioning of the Primo GEN24 Plus. And before we talk about commissioning, of course, we need to talk about how the inverter actually is communicating. And we don't have a display like we have on the previous products, on the Snap inverters, but we have a status LEDs. We have 2 of them, and in the middle of those status LEDs, we have a light sensory button. And this is actually the way how we communicate with the inverter. This is how we can see and respond to the inverter, and where we can open the access point, for example. So just quickly talking about the 2 LEDs that we can see here. The left LED, which is green on this screen, is the operation LED. So it indicates if the inverter is running and what's the status of the inverter, if there is any failure or a standby, something else. And on the right LED, it's the communication. So we can see if the access point is opened. so it's blue blinking then, and a constant blue light would, for example, mean that it's connected to a Wi-Fi, for example. And yeah, the first step we need to do when doing the commissioning is we put the finger onto the middle button here on the sensory button once for approximately 1 second, and then the Wi-Fi access point is opened. So as I mentioned, the right LED is blue blinking, which means the access point is open, and we can proceed with the next one, which is then the connection of a mobile device, of a laptop, for example, to the inverter itself. So yeah, in the schematic, we can see how this is working. So we open the access point and connect to the inverter, do the commissioning process, and we then order the inverter to connect to a local Wi-Fi, for example, and then to SolarWeb. So this is the step that we are doing right now. Yeah, how can we commission? I've already explained the two options. So we have a Fronius app as well available for you. So you can use your smartphone, your tablet as well for the commissioning. The app is called Solar Start and has the big advantage then when opening the access point, you just open the app on your smart device and it's automatically searching for this open access point, and it's connecting to it without any password entrance. So this of course also saves some time. And the second option would be on the right here with a web browser like the laptop, and there we would have to enter a password when we connect to this Wi-Fi access point. But that's of course no big deal. You can find this password also in the user manual. Yeah, so in the web browser then we just type in this IP address down below. This is the same IP address for every inverter, and then we are on the web interface of the inverter and we are on the same step as with the app. So both of these options are available and possible for you to use. Yeah, quickly explained how the commissioning app is functioning. It's 3 very easy steps, which is of course a very nice usability. And these steps are actually can be seen here on this smartphone that is on the screen. The first step is the network connection. We need to communicate to the inverter to which Wi-Fi it needs to connect, and we need to enter the Wi-Fi password as well. The second step is the product setup. So the grid setup, what's the connected PV generator size, is a battery connected, is a backup necessary to set. This is all done in the second step in the product setting. And the last step would be SolarWeb. And at SolarWeb, we can directly put this inverter onto an existing SolarWeb account, for example. Let's imagine that the customer has already registered on SolarWeb. Then he can forward this product and put it onto this account, and there it's then visualized for the customer. So it's a very fast way to have our products commissioned, installed, and commissioned. And one step I need to I want to highlight, because I've already explained the hardware side on it, is the connection of a Fronius smart meter. We already have seen how the installation is going, and the activation has also has to be done as well, of course, at the settings. And here we are actually at the second step here at the product settings. And when we step forward here, we come to the point device configuration. And there we can add a component and we can directly see, okay, I simply select smart meter, Modbus RTU. We select the position. On our case, we have a grid connection point, so the feed-in point, and we just click add, and that's it. But we don't, we need to make sure to don't forget to set this and to activate the Fronius smart meter. Okay, guys, actually that's the end of my presentation so far. Before we end the session, I quickly want to mention a few things. First of all, there are more webinars, online trainings, and even face-to-face trainings coming up. If you're interested, you can check out our homepage, So actually we have also a new trainings format. If you're interested, there is something called online training, which is a face-to-face training with multiple cameras actually in this room that I'm standing here. So we have high quality cameras set up where we can directly zoom in into products, and it's usually takes between 1 and 1.5 hours, and you're happy. We are happy to welcome you there. If you're interested, just register online. It's more or less a short version of a face-to-face training. And as I'm mentioning it, we are also happy to welcome you back in Wels as soon as possible. So in Austria, we are at the first step on the opening process, opening up our businesses here again for customers. And soon we will also can invite you in our trainings facility here for face-to-face trainings. So stay tuned, and for more informations and the contacts, check out our homepage. Every time when you enter our homepage, please make sure to have the correct country selected, because when you're searching for a contact, it's automatically using the one that your country is logged in. So just in order to get to the right contact person, please make sure to select the correct country that you're in. And yeah, regarding this webinar, the handouts, the presentation more or less in PDF form, and also the recording will be sent out to you in the upcoming days, so you can rewatch it. You can share it also with your colleagues if they are interested. And next webinars, I've already mentioned that, can be found online. Okay, so I would say thank you at this point. Thank you very much for listening and for being with us today. I quickly open the question section in order to see if any questions arise during this session. Okay, I think they're already answered so far. If there are more questions, use the chat function and send them through. I will just mute myself and turn off the camera, but I will still be available for you. So thank you very much, guys. Stay healthy, and hopefully we see each other soon in the next session. Goodbye.